Hi, it's Jan Beta, and today I'm going to build the Retro Chip Tester Pro. The Retro Chip Tester Pro is a device that can test all kinds of retro chips from old computers, RAM chips, logic chips, a bunch of other things. The list is pretty conclusive, possibly the best tool that is available currently for testing elderly ICs that are often used in old computer hardware that I work on all the time. So it's going to be a really useful tool for me if I manage to build it. This device was developed by Stefan at 8bitmuseum.de, and he sells the PCB and he has a very conclusive bill of materials on his website, but you have to order the components yourself. And now recently Jacek reached out to me, who owns a small computer shop in Riverhead, New York, in the United States. And he sent me a full kit with all the components we need to build a retro chip tester. Also, he sells these kits on his website, which is AmericanRetro.shop. You can buy the whole kit there with all the components, so you don't have to worry about getting the correct components for this build. Sent me a very nice letter with it. And apparently Stefan was also involved in this getting to me, so thank you both for this, and especially Jacek. Not sure if I got your name correct. Jacek, maybe you're pronouncing it the American way. I'm not very good with pronouncing names. Dear Jan, I'm writing to express my sincere appreciation for your fantastic YouTube channel dedicated to retro computers. I've been a follower since your early days. Your passion for this fascinating era of technology is truly contagious. The way you showcase the history behind the machines and bring back childhood memories is not only informative but also incredibly entertaining. Oh, thank you. As a token of my appreciation and to support your continued efforts, my partner Stefan Slabihut, the developer of Retro Chip Tester Pro, and I wanted to make a contribution of a Retro Chip Tester Pro version kit for your channel. This tool helps diagnose and repair faulty chips, which I hope will be a valuable addition to your restoration projects. It certainly will. Your dedication to preserving and sharing this important part of computing history is truly valuable, and I believe it deserves recognition. Thank you so very much. Eagerly await your next video adventures, and I hope this contribution allows you to continue creating such high quality content. Thank you once again for all the hard work and amazing content you provide. Keep up the fantastic work. American Retro Shop, Jacek Brila from New York State. So yeah, I got this whole kit from Jacek and Stefan. Super thankful for that. This also came with some sweets that I already fed to my kid. Sorry, can't show those anymore. Comes with a semi-populated board here. We already have the Atmel chip in here. That's a microcontroller chip that is the heart of the operation. And some headers and capacitors are already populated as well. And all the rest of this we are going to have to build ourselves. So I'm going to pull up the PDF that's provided on both websites, I believe, and I'm going to go through this step by step. There's quite a few components to solder, so I'm mostly going to show this in fast forward, basically, and then take a look at the result. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They also do CNC machining, 3D printing, sheet metal fabrication, injection molding, you name it. Basically everything the tinkerer needs. Their service is excellent, quality of the products is superb, and their pricing is super reasonable, so I highly recommend checking out the link in the video description should you be interested. Let's get back to our Retro Chip Tester Pro. So, fired up my laptop here with the user manual, which is extremely concise, and probably it's a good idea to print this out. I'm not sure if I'm going to do that yet. I guess I should at least print the bill of materials so I can tick off the components I already soldered, because there's quite a few of them on this board that we need to put on there. There's also a secondary board, which is a power regulating board, because for some older chips, as you probably know if you're working with this stuff, you need some additional voltage rails other than the usual 5 volts for retro chips. You need -5 and +12 sometimes, and this regulates all these voltages. I think the components on here that are already populated mean that this Atmel chip is already programmed. If you buy this as only the PCB and source the components yourself, the PCB is going to come with the Atmel chip, I believe, even in that form, but you have to program it yourself through an ISP header, and you need a little programmer for that, or an Arduino. But that's not that difficult. There's already quite a few videos about this thing where the process is shown in detail. I think Noel made one of Noel's Retro Lab, Adrian Black made one, and several other smaller channels also made videos about this. As usual, I'm the last person to get one of these, but it's the new version. This has, I think, a better user interface because some of the reviewers a couple of years ago pointed out that it would be nice to have one more button for a back function, which this has now, I believe. That's all pretty neat. Let's start building this thing. And I think I'm going to print out the bill of materials so I can tick off the list once I've soldered everything. Of course, you want to have a bit of an air filter going. I'm going to have this little one here sitting on my bench top, and I'm going to have another one under the table here that has a bit more airflow. Activated carbon filters to minimize my intake of solder fumes, which is always a good idea if you're soldering a project like this. I'm also going to wear an anti-ESD wrist strap, and this bench top is also connected through a resistor to mains earth, so it is connected to ground. Basically, we don't risk zapping any of the components that are a bit more susceptible to electrostatical discharge. I think that's pretty much all I can say at this point. I'm going to build this. I'm going to show you a little montage of me soldering this, and whenever I encounter something that I consider important, I'm going to tell you. In this kit, the components all come neatly bagged, different bags for different values of resistors even. I suppose there's not too much that can go wrong. I'm just going to follow the build instructions, and the bill of materials, I printed that out to tick off the components I already have in there. I'm going to do one value at a time, starting with the lowest height components. That's always a good idea, which are the resistors and diodes and such. And then we have a bunch of transistors and headers and switches and LEDs. This PCB, as you can probably see on camera, also has the values of each component printed on it, so that's super helpful with kits like this. And it also has like R23, R28. It also has the designators for these, but it also has the values, so that's super helpful. Yeah, and for the standard through-hole components, I tend to just bend them, pre-bend them, and then bend the legs on the flip side of the board outwards, and then solder them in so they hold in place while I'm soldering them. Yeah, let's start with the resistors. The first ones are the 1K resistors. I already have them in here. So we need some components for this board as well. Most of the components are going to be on this board, obviously. So let's start with the 1K. Next up, we have the 470 ohms resistors, and that's the largest count. There's 54 of them. So I think what I'm going to do is to populate a couple at once and solder them in. Bear with me. The next one I'm about to solder is R75, and that is for the display, actually, for the backlight of the display. That's a 220 ohms resistor, and you don't have to solder this in case your display that you're planning to use has a resistor for the backlight already on board, which most of them have, I believe. I'm still going to solder this in because I don't know about the one that was provided here, and we can still bridge that in case we don't need it, just with a wire on the backside or something. And in case we need it, the display is not going to burn out when we first power this on. And that's all the resistors for this board. Should go with the diodes next, I guess. So there's two different kinds of diodes. These 1N4733, that's 32 diodes. And we have some 1N5817s, that's 11. Same thing as for the resistors, except these have a ring on one side, these have a dark ring, these have a bright silver ring, and that's the cathode, the negative side, that also has a ring or a stripe on the circuit board for all the positions where there's diodes, for example here. The ring should be aligned with the stripe to have it in the correct polarity. So that's all our diodes in on the main board. So D44 is optional in case you don't have the little DC regulator board that we have and you are going to power this through the barrel jack. I think that's for reverse polarity protection on the barrel jack. So maybe some other diodes, the LEDs, light emitting diodes. So similar to the other diodes, these have an orientation. They have a cathode and an anode. And the anode, the positive side, is always the longer lead. So we're going to orient them accordingly. And there's a couple that go on this little regulator board and a couple that go here with different colors. One active power VCC. So these two should be red, I think. And the activity LED is a yellow one, or in this case, an amber or orange one, which is pretty cool. So we're also going to need some wire jumpers here, here, and here. And I'm just going to use component leads for these two because they're short enough. The cutoffs from some of the components we just used. And this is going to be a wire, an insulated piece of wire. So I just read up in the assembly manual a bit more, and it's actually a good idea to populate this optional barrel jack. There's a voltage regulator and jumpers and a diode and the two capacitors here. So we are going to populate that, and then we're going to have all the options to power this with the power module, without the power module, this secondary board, and via USB or a barrel jack. You can just populate this and have all the options. So that's what we're going to do, I suppose. Yeah, and I also think that's what I want to do next. These larger footprint regulators, 7905, that's probably for, yeah, that's for the power board. It also says DC on here in case it's only for the power board, and it says 19 and DC for the component number, and on the DC board in case it goes on both boards. So we're going to use one of these. This is a 5-volt linear regulator, 7805, very classic component. That one goes here and should lay flat on the board. You can tack it down with some tape or something. I like to just hold it in place and soldering one of the pins. You can solder the rest of the pins. It looks a bit crooked, but it's going to be okay. So that's our 7805. And we have Q31 or 32. That's this part here. That's our MOSFET. And the small little footprint there is for an alternative surface mount version. I think it is probably time for the capacitors. So a few different kinds of capacitors as usual. These are ceramic small 100 nanofarad capacitors. We have some electrolytic capacitors, and we also have these polyester film capacitors, these yellow things. We have a polyfuse that looks a bit like a capacitor but is more squared. And I'm also going to solder in these relays. These are small little relays to switch the voltages around, and these go here. And we have a 16-pin chip socket that also goes in now. And then the connectors for power switches, things like that. I'm going to do those one by one, I think. Yeah, let's just start with the capacitors. Polyester and ceramics don't have a polarity. You can put them in either way you want. The electrolytic ones have a polarity. They have a stripe on the negative side. And also these relays have a stripe that should be oriented downwards, I think, from this perspective. It's also very clearly laid out in the manual. So yeah, side with the stripe should be oriented facing me from this perspective. And of course we need to populate that diode that I left out earlier. Now for this electrolytic capacitor, I've seen some videos where people found that this is interfering with the display, which goes on top here in case you stand it up. So I just put it on the side. C4. We're going to do the smaller transistors. There's a whole bunch of them. The transistors are shaped in a certain way so that they have a round side and a flat side, and the PCB has that footprint on the silk screen, so should be pretty difficult to get them in the wrong polarity. And yeah, I usually bend the legs a bit before I insert them, so it's easier to fit these. So the next ones are BC547C. And that's all the transistors in. Okay, only a couple more connectors and things like that to go. And then we're ready to test this thing. Oh, and of course we have to build this power regulation board. There are two different options for the micro USB connector. This one just has two connections because it's only used for power. This is one that has surface mount connections here. So you can use a number of different form factors of these. Large USB, old school. Now for these switches, tactile buttons, there was one in the kit that was smaller than the other ones, but I found one in my parts bin that is the exact same height as the others, so I'm going to put that one in. Might be a good idea, and I'm just going, if I ever decide to put this in a case, I'm just going to modify the case, I think. So the buzzer, which has a volume control, which is a super nice feature because these things can be rather annoying, as you probably know. And then I think the final thing is the socket where the chips actually go. On this board we have to build the smaller board as well. Kind of fiddly. It's not a great socket. Possibly if I can ever source a genuine 3M socket or something like this. This is one of the fake ones. There's a lot of fake SIF socket, zero insertion force sockets around that, which are a lot less expensive, but also not the best quality often. Yeah, they do work. Nothing wrong with them really, functionally, but they are not built to the highest standards. This one is a bit warped. I think we are ready to build the other board. So this is what this looks like when all the components are on the PCB. As I said, there's a couple of options for these power inputs, and some things got changed slightly. There's an additional button here and some jumpers for the latest revision here. But overall, this is how this should look. So let's build the remaining board that we have. There's a lot of other expansion boards that could go with this. This is the main attraction here. This is a voltage regulator. The manual recommends a Recom one, but this is going to do. That's a Fink brand. The Recom ones are really good quality, but they are also super expensive. So I'm going to put this in here. So that's pretty much all the components. The pin headers that go on this go on the underside because it's supposed to plug into our pin sockets on the main board. And that's our DC board done. And here's our display that we're going to solder this to. I'm going to plug this into the header here so we have the correct spacing. And I think I'm also going to put these standoffs in here just to make sure that we have the correct spacing for this, like so. Yeah, can't go anywhere really. I'm going to solder this, and these standoffs are going to go everywhere basically. So there's a lot of standoffs in the pack here. This whole board is going to be lifted from the surface. So now we have everything assembled basically, and I'm going to clean these boards, all the flux, and check them for shorts or stray solder that I forgot to remove. That's a very important step. Cleaning with IPA and a brush and some Q-tips, and then checking for bad joints, missing joints, joints that are connected that aren't supposed to be connected, things like that. You have to set some jumpers according to how you're going to power this. With this configuration that I'm using here, we don't need any jumpers because we have the DC to DC board. Still needs a bit more cleaning. If you want to use this internal power regulator, voltage regulator, you have to set some jumpers. But we are going to be fine like this, I think. If I interpret the instructions correctly. I'm very eager to test this, so I'm going to stop cleaning and put it all together. And I'm going to put the standoffs in and then the boards and see which standoffs need some additional screwing down with these little nuts that are provided here. Some of these standoffs just screw into each other. The ones that hold the circuit boards, the secondary circuit boards. Not going to fully screw this down yet, because we need to test it beforehand. This looks really nice. Okay, the chip. This needs to go in the correct orientation. Pin 1 facing there. Usually there's a little notch on the chip to indicate the direction of pin 1. There we go. Should be completely and utterly fully assembled now. So, moment of truth kind of moment. I'm just going to use a USB power supply. This came with a Raspberry Pi, I think. And this should fit our micro USB. Okay, in theory this should power on. It should be programmed and everything. So let's try that. Okay, plugging in now. Yay! Totally powered up. Display is lit. Let's see if we can bring the contrast to something we can actually see. Yeah! Ooh! It seems to work. You can't see it. It actually looks good, the display. So it seems we need that resistor there for this kind of display. It's bright and all. It still has the protective film on it. Okay, I think there's no more soldering needed. This thing seems to work fine. And we are going to remove the protective film here so you can see better and I can see better. So let's power it on again. Yeah, the camera angle is not ideal. The display seems to have problems with the angle, but it is very nicely readable. I'm going to put the remaining nuts on and then try this out for a bit. So I got myself some chips I want to test, and you can actually go through a massive list. EEPROMs, ROMs, logic chips, custom chips. You can put your own definitions in there. Let's do something common, I guess. I think I have some RAM chips in here somewhere. 4116. So that should be in this category. 4116. Okay. Oh, it reset because I didn't have the chip in. It starts the test immediately, it seems. Okay, let's select 4116. And I'm going to put a 4116 chip in there. That's allegedly broken. So the chips should be aligned to this side here. Should clamp down. And we should start the test with OK. Okay, it said da-da, so it's broken. Let's test this again. Okay, that was quick. This one is really broken. That's another 4116. Oh, that one might actually be good. This has a very nice user interface, progress bar and everything. Test passed. Okay, I marked this as bad with a question mark. This might already have paid for itself. I didn't pay anything for it, except for some customs fees. But yeah, that's very cool. I'm so sorry you can't see the display. It looks way better in person than it looks on camera. I'm not sure how to make that work. So this one seems to be good. So I can just wipe away my markings there. One super useful feature of this is that it doesn't send voltage to this socket unless you push the OK button. You can see that by this LED here that indicates voltage going through the socket. And then there's this activity LED while the tests are running. So this one is actually good. That's interesting. One thing that got criticized in the other videos is that there was no back function, but now this can scroll in both directions and has a back function here. And yeah, one additional button. Yeah, let's see if we can test some logic, I guess. Yeah, that's a 7406 I want to test. Let's put that one in there. It's one I think that came from a C64 that I repaired at one point. Okay, let's test this. Chip failed. Oops, that's bad, I guess. Okay, that's a bad 7406. I think I have another one here. 7406. This one should be good, actually. It's not marked. 7406. That may be good, maybe not. Chip okay. Okay, that's really quick too. But it just tests if the chip reacts to the logic table that it's supposed to react to, I guess. Yeah, it can do a lot of different logic, even 4000 logic. And some Soviet chips, USSR chips. So this thing really covers most ICs used in old computers. PALs. Joystick tests. Yeah, we can have several adapters for this, and it seems you can have a joystick adapter as well. Frequency counter. You can use this as a kind of a measuring tool as well. And what it can also do is you can plug in an SD card reader, writer, in here, and then it can read the contents of ROMs actually and save them to the SD card. I don't have one yet, so there's probably going to be an upgrade video at some point. Let's test a ROM. I don't know if I have a ROM here. I think we have a C64 ROM here. So I dimmed the lights a bit. Maybe you can get a better idea of what the display looks like in person. And we should have a 2364 ROM here. Not quite sure what it is, but this thing also has a list of ROMs in there. I think it's a C64 kernel ROM or basic ROM, but I'm not quite sure. The numbers, I can't remember them. Yeah, let's see. Commodore. Okay, it actually has something on it. So that's our checksum. So the ROM seems to be alright, even though it's marked red. I didn't mark it, but might be an okay ROM. Yeah, this thing can do so many chips. I can't possibly test all the functionality here. And these are the dreaded MT-RAM chips that are almost always broken. But we're going to find out shortly if this one's broken. Okay. It's not even recognized as a 4164. Some of these are badly shorted. This one is testing actually. And it does pretty in-depth testing here. So this MT-RAM seems to be alright so far. That's interesting. And of course it tests all kinds of different methods, writing random numbers in there, reading them out again. It's a pretty in-depth test, way more in-depth than our Arduino tester that I built a while back, or actually built two of them. And I'm going to build one more of those, because they are way less expensive than this and still quite a good test. So this one is actually okay. Interesting. Yeah, so this is what this thing does. It provides 3 different voltages. The voltage rails are indicated by these LEDs. The VCC LED doesn't seem to work. Maybe I'll have to look at that. I think this should light up while the tests run. This is actually working too. Yeah, the VCC LED should light up, I think. Not sure if I put that in the wrong way. Maybe. That would be kind of embarrassing. Everything else seems to work, but one LED doesn't light up. But that's the way things go sometimes. So I have 3 RAM chips that seem to be working. That is a very useful device already. Yeah, this thing is amazing, and some of the earlier criticism doesn't apply anymore because the user interface just got a whole lot of improvements and it's really easy to navigate through this list of chips. They are kind of divided into categories, which makes things a lot easier. And there's a lot of different types of chips you can test with this. And the list is actually expanded all the time. So there's new chips added to the list all the time. At some point, there's not going to be more chips to add to the list, I guess. But yeah, this can test a lot of obscure stuff as well. And it's especially aimed at the retro computing enthusiasts. So very much worth it if you are into that hobby. And as I said, there's plugins, like hardware plugins, where you can have adapters in the IC socket that can test even more stuff. Even a joystick test is implemented now. And you can reprogram the firmware through the ISP header. I would have liked to show you, but I can't find my ISP USB adapter at the moment. I know I have a bunch of them somewhere in some box in the lab, but I didn't find them. I'm going to find them eventually, and then I'm going to make another video about that. I'm also going to get one of the enclosures for this. As I said, there's one available from Plexilaser, just clear laser cut acrylic that looks amazing. So I'm probably going with that one, and I'm going to use this in future videos anyway. I think that's it for today. Not much more I can say about this thing at this point, except for it's an amazing product. It is pretty pricey, but there's a lot of components on here. And I think that justifies the price tag that this comes with. I found some sellers on eBay that sell these pre-assembled even for a much steeper price point. But if you are into repairing retro machines, you are probably going to have fun with building this yourself. The links are in the video description. The 8-bit museum.de is linked in the video description. The original maker of these, or the inventor of this thing, Stefan, and also the link to AmericanRetro.shop, where you can get this kit that I just built here. Hope you enjoyed this, hope it was informative and maybe a bit entertaining. As usual, special thanks to everybody who supports me on Patreon or the YouTube channel memberships page or Ko-fi or elsewhere. Very much appreciated. Hope to see you again on this channel sometime. I'm Jan Beta. Thanks for watching. See you next time. Bye.